Hello, grade 12. Welcome once again. We are still doing the grade 12 mathematics summer lessons, and today we'll be focusing on session 3, where we'll be mainly focusing on the sum of arithmetic series. Don't forget, we are still doing grade 12 online maths. Okay, let's quickly take a look at the content outline. Um, So far in our session 1, we covered arithmetic sequences, right? And then we did session 2 where we covered geometric sequences. And this is unit 3 and session 3 where we are going to focus on what? On the sum of arithmetic series. Okay, so don't forget you are still using Platinum uh, mathematics textbook, learner's book, grade 12. Okay, Unit 3, Sum of Arithmetic Series. Hmm. So we have started with series now, right? So in the previous grades, you've been learning about sequences, and in grade 12, they now introduce you to series. So it's not really a uh, big concept. It's very basic. That's why they call it the sum of arithmetic series. So really, you must understand what is an arithmetic series and how is it formed. So an arithmetic series, according to the definition given here, is formed when the terms in an arithmetic sequence are added together. That's why we call it the sum of arithmetic series, because what? We are adding the terms of arithmetic sequence together. Now they form a series. But because that those terms were for arithmetic sequence, then they will form what? An arithmetic series, right? So because we are adding those terms. So now, um, there's an algebraic proof that applies to all arithmetic series, and it's very examinable, right? So they can ask you to prove this formula for sum of an arithmetic series. Remember, we are going to be adding terms of an arithmetic sequence, right? So for example, let's say for instance I'm adding 1 plus 2 plus 3 plus 4 plus 5 plus up until maybe I add up until 1000, right? So you can see that this is a sum of arithmetic series, right? Because the terms here, they are forming what? They are forming an arithmetic. These are terms for arithmetic sequence because we have a common difference of 1, right? So if maybe I'm required to calculate the sum of all these arithmetic series, um, it's gonna really take me a lot of time to actually add them together up until 1000, even though using my calculator, because you have to add 1 2 3 4 5 6 7 8 up until you add up until 1000. So we have a lot of terms to add, right? So mathematicians, one of the mathematicians come up with this formula that we can use, and we call this formula the sum of an arithmetic series, where you just need to substitute some of the things there in order to get the answer of the whole sum, right? So this is the formula here. It says Sn is equal to n over 2. Let me delete this first. Sn is equals to n over 2, open brackets, 2a plus n minus 1d, right? So let me put this in bracket so that you may not be confused. So this is the formula. It says Sn equals to n over 2, 2a plus n minus 1d. So with this formula is the formula for sum of n terms of an arithmetic series. Let me write it also. This is the formula for sum of n terms of an arithmetic series. So if we are adding terms of that forms an arithmetic sequence, we are adding them together. Then to get those sums, other than us going to do it manually and patching a calculator like that, we can just simply use this formula, right? So now here I just want to show you how you can prove this formula, because this is examinable. They can ask you that prove that the sum of n terms of an arithmetic series is equal to Sn is equals to n over 2 2a plus n minus 1d, right? So they can say, in other words, they're saying prove this formula, right? How did they get this formula? Okay, so in proving this formula, what you do, because we want the sum of n terms, right? We are adding terms of an arithmetic sequence. We know that the first term is a, right? The next term is what? Is a plus d, right? Because to get the next term in an arithmetic sequence, we add the common difference on the previous term, right? Okay, so the next term again, the third term, it will be a plus 2d, right? Because d plus d will be 2d, then a plus 2d, like that. Okay, so this will add them up until we reach our last term, right? Up until we reach our last term, and I'll just put the letter L there to represent the last term. Don't forget, when we are doing session 1, we said the last term is the same as Tn. Okay, but for now, let's not really entertain that, uh, and let's see how it goes. Okay, so we are adding up until the last term, but someone might choose to say, okay, we are adding up until the last term, but what happens if I want to go back from the last term? Because to go in front we were adding d, then to go back we'll be subtracting what? We'll be subtracting d. So this will be the same as L minus d, the second last term, right? L minus d plus another second last term. If we are moving backward, it will be L minus d, and we subtract another d, then it will be what? L minus 2d, L minus 2d. So this forms the sum of an arithmetic series, and I will call this my equation 1, right? This is my equation 1. So what we did here is simply to add the terms of an arithmetic sequence, as because to get the arithmetic series, or to get the sum of an arithmetic series, we need to add the terms of an arithmetic sequence. So we are just showing you how to prove this formula. Okay, so again, now we have formulated our equation 1, right? So in order to formulate your equation 2, what we do really is we can start adding from the last term up until going backward, right? For example, so if I have if I want to add 1 plus 2 plus 3 is the same as starting with 3 plus 2 plus 1, right? 3 plus 2 plus 1. These two are the same things, right? So in addition, the order really doesn't matter so long as you're adding all the terms. So it's fine. So to get your equation 2, really what you do is you start from the last term and you add them going backward, because it's the same thing. You're not changing or breaking any mathematics rule. So in doing this, make sure that those terms that you are adding, they are really aligning with those terms in those position on the equation 1, right? So L will align with A there, plus if I move back there, we have L minus D. If we are moving back, we have L minus 2D, L minus 2D, then plus we are going back, we have A plus 2D, then we have A plus D, then we have what? A. So this is our equation 2. How did we get equation 2? We added the sum from the last term up until going to the first term, like that, right? So now what we're gonna do is to say equation 1 plus equation 2, right? We are going to add equation 1 plus equation 2. So remember, this is just a proof of this formula. Equation 1 plus equation 2. So we are saying Sn plus Sn. In this case, Sn plus Sn is going to be A plus L. If you add these two, it will be A plus L plus, so a plus d plus l minus d. So d minus d will cancel out each other. We'll be left with what? With a plus l plus 2d minus 2d will cancel out each other. There also will be left with a plus l plus up until we are going to the last term. Minus 2d plus 2d cancel out each other. We'll be left with a plus l. Minus d plus d will cancel out each other. We'll be left with a plus l. Then here also we can see it's a plus l. So this is a plus l. So we can simplify and solve for our Sn, right? Sn plus Sn will be 2Sn. So now look, we have a plus l, 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 right? So we can write this in a simplified way or in a reduced or condensed way, right? How can we do this? Okay, let's take for instance, let me just use a different color maybe. Let's take for instance we had some maybe it's 3 plus 3 plus 3 plus 3 plus 3, right? And we want to write that in a simplified way. How can we write that? So one can do this. We can actually count how many threes are there, right? So we are saying the number of threes, then we multiply with what? With 3. So to write it in a simplified way. How? So if we know the number of threes, for example, in this case, we have 1, 2, 3, 4, 5. We have 5 threes, right? So it will still be the same if I'm putting 5 times 3. It will give me the same answer of what? Of 15. Also there, I'll get the same answer of what? Of 15. So to write this thing in a simplified way, we can just count the number of threes multiplied by what? By 3. So that's the idea. Okay. Okay, now we can relate it to this one. We have a plus l, a plus l, a plus l, a plus l, a plus l. So to write it in a simplified way, we can just count the number of a plus l. That is the number of terms that we have that we are adding. Then multiply by what? By a plus l. By a plus l. Now, after doing this, it's easy to solve for Sn. We're just going to divide both sides by what? By 2. We divide both sides by 2. These 2 cancel these 2. Then, let me do this. You have your Sn is equals to n over 2. We can write it n over 2 into a plus l. Into a plus l. Sorry about this. N over 2 into a plus l, right? Okay, now remember from our session 1 we said the last term is the same as what? As tn. So don't forget the last term, which is l represent the last term, is the same as tn. And because this is an arithmetic sequence, tn of an arithmetic this is an arithmetic series, but we are adding terms of an arithmetic sequence. So tn of an arithmetic sequence is a plus n minus 1 d. So where there is l, we can replace by a plus n minus 1 d because it's tn. So we can simplify our Sn to be n over 2 a plus, our last term is what? Is tn, which is a plus n minus 1 d. A plus n minus 1 d, right? Then let's simplify our equation. It's n over 2 into a plus a, 2a plus n minus 1 d, 2a plus n minus 1 d. So that is how we prove this formula that says Sn equals to n over 2, 2a plus n minus 1 d. So this proof is very important because it's examinable, right? It's examinable. They can give you a question, prove that the sum of n terms of an arithmetic sequence is n over 2 into a plus n minus 1d into 2a plus n minus 1d. So you have to follow this proof in order to prove that. Very simple. First equation, you show them while you are adding the terms of an arithmetic sequence. Second equation, you just add those terms from the last term going back to the first term. Third step, you add the two equations. After adding the two equations, then you can simplify and solve for your SN. Okay. Okay, great stuff. Let's now that you know how to prove the formula for calculating the sum, if we are summing up the terms of an arithmetic sequence, thus to form an arithmetic series. Let's quickly now look at this worked example one and see how that formula can really help us in calculating. So the question says determine the sum of an arithmetic series. You are given 4 plus 11 plus 18 plus 25 plus up until they are adding it up until 368. So now the formula that we prove say Sn equals to n over 2. Sorry about this. N over 2 2a plus n minus 1d, right? There's two formulas really. There's another one, Sn equals to n over 2 a plus last term, the one that we proved before substituting our last term by tn, which is a plus n minus 1d. Okay, so now these two formulas, they're the one that you're gonna use to calculate the sum of an arithmetic series. So now this formula is used when you have the last term used when we have the last term, right? It is used when we have the last term. If we're given the last term, so we can just simply go and use this formula. Now this formula, this side, we're gonna use it when we don't have the last term used, when we don't know or we don't have the last term. So that's the formula we're going to use. So like I said, Sn stand for what? Stand for the sum of n terms. So for example, if we are adding 30 terms, so it will be S what? S30. So we say Sn because we don't know how many terms you are adding. So, and also it's just the general formula there of arithmetic series. Okay, so where n stand for what? You already know the position of terms, also known as the number of terms. And we know that d stand for what? The common difference. D stand for the common difference. And we know that a stand for what? The first term. So our a is our first term, which is t1. And L from this side, L stands for what? The last term, which is also the same as what? As Tn. The last term, which is the same as Tn. Okay, so now look at your arithmetic series and just uh, 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 um, take a look at it and think of the formula that we're gonna use, right? So you ask yourself, do I have the last term in this series? Yes, we do have the last term because they showed us adding this series up until they're going like that. Those dots, they're approaching infinity. Then they say plus 368. It means 368 is our last term. So this is the formula that we're gonna use to calculate. Okay, let's get the rest of the unknowns and use the formula and calculate this out. Okay, now let's go and look for our unknowns. We need to know how many terms we are adding before calculating the sum, right? And that is n. So from this series, you can't really tell how many terms they're adding, but we can just simply calculate it, right? Because they showed us adding 4, 11, 18, 25 like that up until they're adding to infinity, up until they reach the last term 368, right? But now, because we know the last term, is the same as what? As Tn, right? And Tn is the same as a plus n minus 1d. It means if we get the common difference, if we get a and substitute our Tn 368, we can solve for n and check how many terms they added them together, right? Okay, so I'm gonna replace Tn by 368, and a is our first term, which is 4 plus n minus 1. Let's go and calculate the common difference. So we know common difference, second term subtraction the previous term, third term like that, subtraction the previous term. Okay, so term number 2 it's 11 minus, I'll put it in brackets, so don't forget every time when you put subtraction, whatever that follows, put them in brackets so that you may not make a mistake. Okay, so term number 3 is 18 minus the previous term, which is 11. I'm simply gonna put it in brackets. 11 minus 4 is gonna give me 7, right? And also let me check, 18 minus 11, it's also 7. It's also 7. So the common difference is what? The common difference is 7. So we have a common difference of 7. Okay, yeah, that's just it. We're gonna replace our common difference of 7 and we calculate the number of terms that are being added, right? So I put 7 there. So to solve for n, I'm gonna take 4 to the other side. It's gonna be 368 minus 4 is equals to n minus 1 multiplied by 7. So here I'm gonna left with 364, because 368 minus 4, 364, then I can equals to n minus 1 times 7. I can divide both sides by 7, and when we divide both sides by 7, it's gonna be 364 divided by 7, which is gonna give me 52. 7 and 7 cancel each other. I'm left with n minus 1. Then I take 1 to the other side. 52 plus 1 is gonna be 53. So there's a total of 53 terms that are being added together. So my n is 53, right? So our a, now we go to a. Our a is our first term, which is 4, right? Okay, our l, which is our last term, is the same as tn. It's our last term there, is the same as what? 368. Then I can use my formula and substitute my values and then get my sum. So it's sum of 53 terms. Where there is n, I'm putting 53. So it's 53 over 2. My a is 4 plus my last term is 368, right? So I'm just gonna punch a calculator and see the answer that I'm gonna get. Okay, so the final answer got 9,858. So when we sum up all those 53 terms, that is from 4 up until 368, according to that sequence, we gonna get 9,858. Okay, so in this case, this was the first example where we were given what? Where we were given the last term. Okay, let's look at a different example. Okay, example 2, and it says determine the sum of the first 20 terms of the arithmetic series. They're given minus 15, minus 9, minus 3, plus 3, plus, and they give you the 3 dot to show that the sequence is still going, right? So in this series, not the sequence, sorry, but series. In this series, we don't have the last term, right? We don't know what is our last term. This is because they just show us the dot that the sequence is still continuing. But if maybe they said plus maybe 9, something like that, then we would know, oh, it went to dot dot dot, it continued like that up until it ended 9. Then we'll say 9 is our last term. But they didn't do that. They just show you those 3 dots to show that the sequence is still continuing, right? So you don't have the last term. What's the formula we're gonna use? Is the other formula, that we just proved, Sn equals to n over 2, 2a plus n minus 1 d, right? From this formula, right, we need to know our number of terms that are being added. So the question wants the sum of the first 20 terms. So they already give you how many terms they're adding, right? So our n is what? Is 20. Then our a is the same as the first term, and our first term is negative 15. Negative 15 is our a. Then our d, we get our d by saying the second term subtraction the previous term must be the same as term number 3 subtraction term number 2. Okay, so term number 2 is minus 9, right? Minus of the formula, then whatever comes, you put it in brackets to avoid making mistakes. So minus 15 there. Term number 3 is minus 3, minus into term number 2, you put it in brackets, right? After minus, just make sure you put it in brackets, minus 9 like that. So it's gonna be minus 9, negative and negative, positive 15. Then this side is minus 3, negative and negative, positive 9, right? So minus 9 plus 15 is 6, right? It's 6. And minus 3 plus 9 is what? It's also 6. So we know the common difference, our d is equals to what? Is equals to 6. Okay. Okay, after calculating d, we can now go back to the formula and just calculate the sum of the first 20 terms. So a sum of 20 terms where there is n, I put 20 over 2 into 2 multiplied by our a, which is minus 15, plus our n is 20 terms minus 1 multiplied by d, which is 6, right? So the way I wrote this, that's exactly the way you should punch it on your calculator in order to get the answer. Okay. Okay, so the final answer I'm getting 840. So this is, oh, sorry about this. So this is 840, and this is the sum of the first 20 terms, right? So that's basically how you calculate this if you're not given the last term. Okay. Okay, great. So just to flip this lesson a bit, uh, we also gonna focus on how we can use this sum formula to calculate questions that are related to arithmetic series. And what actually happens here is that they will give you a sum formula in terms of n or in terms of any letter they might choose, and they will actually require you to calculate, maybe you can see from this example 3, the first 3 terms of the sequence, right? So most of the learners just think this question require S1, S2, S3. Not really, but it really requires uh, the terms, not the sum, right? But they will give you a sum formula, but they want you from the sum formula to calculate what? The terms of the sequence. So they don't want S1, S2, S3, but they need the term. In other words, question number 1 needs term 1, term 2, and term 3, right? Okay, so you're gonna learn how we can use some formula to calculate the terms of a sequence, right? So there's a general standard formula. It says if we want to get the terms of a sequence, then if we want Tn is the same as Sn minus Sn minus 1. So that's how you can actually calculate a term using this standard general formula. So Tn is the same as Sn minus Sn minus 1, and it has been proven. You don't need to know how to prove this, but you just really need to know that this is the general formula of what? Of calculating Tn if we are given Sn, the sum of an arithmetic series. For example, if I want term number 2, we know that this will be the same as S2 minus S2 minus 1, right? And this, if I simplify, is S2 minus S1. right? If I need term number 3, it's gonna be S3 minus 1. This is S3 minus 1, S2. So you can actually get the trend in which we can calculate the terms if we are given the sum formula. So if I need term number 4, I can see the trend is just saying that term minus the previous one. So um, term number 4 given sum formula is the same as S4 minus S3, the previous one. Term 100, I also know if I'm given some formula is the same as S100 minus S99. So that's how you do it. So term number 1 will be the same as S1 minus 1. So this is S1 minus S0. S0, we don't have sum of 0 terms. Sum of 0 is 0, right? Sum of 0 terms is 0, so that will just go away. So S1 is the one that is equals to, term number 1 is the one that is just equals to S1, because S0 is not there. Sum of 0 terms is 0. So because you are not adding anything there. So term number 1, S1, term number 2, S2 minus S1. But you can really just know this general or standard formula here in order to calculate. Okay, so now the first question says determine the first 3 terms of the sequence. They need term 1, term 2, term 3, right? We know that term number 1 is the same as S1. So where there is n, we're going to replace with what? With 1. Then we solve for our term number 1. So on our formula there, we're given the formula there. We're going to replace with 1 and we calculate our term number 1 like that. Okay. Okay, we just gonna replace that and calculate and see. 1 squared is 1, 2 times 1 is 2, plus 9 is gonna be what? 11, right? So term number 1 is 11. Term number 2 is the same as S2 minus S1, don't forget, right? But we need to have S2, so S2, where there is n, we're gonna replace by 2, right? So where there is n, I'm gonna replace by 2. It's gonna be 22 squared plus 9 into 2. Okay, minus, don't forget, after every minus, just put what follows in brackets, minus S1, right? But we had already calculated S1 in the previous question. It was what? It was 11. So this we're gonna simplify it. Let me put this squared properly. Sorry for the background noise. If I'm just outside and I think it's sort of disturbing. Sorry about that. Then 2 squared is 4. 4 times 2 is 8, right? 8 plus 9 times 2. 9 times 2 is 18. Then it's just gonna be, I think, 18, 26, right? 18 plus 8 is what? Is 26. So this will be 26 minus minus 11. Then it will give us I think 14, not 14, 15, right? Okay, so 15 is the answer here. Okay, so this is term number 2. It's equal to what? It's equals to 15. Okay, let's go to term number 3. You have to know how to express this in terms of the sums. If you are given the sum formula, S3, term number 3 is S3 minus S2, right? If you are given some formula, that's what you do. Okay, we have to calculate S3. So when there is n, we're gonna replace by 3. 3 squared plus 9 into 3 minus S2, right? Minus S2. So you know that this was the answer for S2 as we calculated here. It was what? It was 26. I'm just going to put that in brackets just to avoid to make any mistakes. So 2 into 3 squared plus 9 into 3, just using my calculator very fast, it's 45 minus 26, right? So 45 minus 26, it's what? It's 19. So these are the first 3 terms of the sequence. I hope you understood that. Okay. Okay, let's come to number 2 now. We just calculated the first 3 terms, and I hope you understood that. And number 2, determine the 12th term by using the formula Sn is equals to 2n squared plus 9n. So yeah, they want the 12th term. So term number 12 will be the same as S12 minus S what? S11. So we have to calculate S12. Where there is n, we're going to replace by 12. To be 12 squared plus 9 into 12 minus, don't forget we have to put whatever comes after negative in brackets to avoid making mistake. So it's 2 into 11 squared plus 9 into 11. It's about to rain here. Let me quickly do this. Okay. Uh, so it's 2 into 12 squared plus 9 into 12. So it's giving me 396 minus, it's 2 into 11 squared plus 9 into 11. So that one is giving me 341. So 396 minus 341 is giving me 55. So term number 12, it's what? It's 55. Okay. Okay, let's quickly do number 3. It says determine the 12th term by determining the formula of the nth term. Okay. Um, okay, yeah, let me just put our 12th term was equal to 55. So now they want us to determine the 12th term by first determining the formula of the nth term. So they want us to get the 12th term using the nth formula, right? So we're gonna calculate the nth formula. Don't forget we have already calculated the first 3 terms of the sequence, 11, 15, and 9, right? Let's quickly get the common difference. 15 minus 11, it's 4. 19 minus 15, it's also 4. So common difference is 4. Then we can get our Tn. Tn is a plus n minus 1d. Our a is what? Is our first term, which is 11, n minus 1. Our common difference is 4. Then our Tn will be 4n minus 4 plus 11. And our Tn will be what? Will be 4n minus 4 plus 11 is going to give us 7, positive 7, right? So this is the formula of the nth term, and they want us to calculate term number 12 using it. So term number 12 is going to be 4 into 12 plus 7. Then I'm just going to say 4 into 12 plus 7, and it will give me 55. So you can see that getting the terms using some formula and actually using the nth formula, it's actually the same, because there's this standard general formula that we can use, or we can just use the normal nth formula that we know. So T12, it's 55. So someone might like to get this nth formula using this general to say Tn equals to Sn minus Sn minus 1. Then they will say Tn equals to Sn. Our Sn was 2n squared plus 9n minus into Sn minus 1. So it's 2 into, where there is n, we subtract 1 squared plus 9n minus 1, like that. Then you simplify it. You'll see once you simplify it, it will still give you 4n plus 7. Then you're just gonna substitute 12 there, and you calculate for what? And you calculate for T12. Okay. Okay, great stuff. Fun activity. It's time to engage now, and let's see who can actually get this one. You can pause the video now and read the question, and try to answer it, and drop your answers on the comment section, and I'll comment from there, and we'll actually take it from there. So it says the second term of the sequence is 17, and the sum of the first 6 terms is 147. So they need you to calculate the first 3 terms and the nth term, right? They need the first 3 terms and the nth terms. So, and the nth term. So just pause this video, try to answer this question, drop your answer in the comment section, and we'll see how it goes. Okay. Okay. We have reached the end of this session. Don't forget we were doing session 3, the sum of arithmetic series, and you actually learned how to prove the sum of arithmetic series, how to calculate the first two example, how to calculate those sum of arithmetic series. Another example, how to use the sum of arithmetic series to calculate terms and to calculate the nth formula, and also the fun activity exercise there. Okay, thank you very much for joining. Thank you for watching, and that's it from me. See you on the next session, session 4, where we'll be focusing on the sum of a geometric series. Okay, thank you very much and enjoy the rest of your day. Goodbye.